All right, let's work. Pathways 2.93 asks us to correct the names of 3 compounds. I saw this problem in your book. I thought it was a little bit funny because as you're learning to name compounds and recognize the names of these compounds, it's pretty common to make the types of errors that are exhibited here in this problem. When I'm grading papers very often, I see this type of thing. So I figured it would be useful to work it for y'all. 3-part problem, ABC. Part 1 gives us this formula, CuI. And they claim that the name for that material is cobalt-2 iodide. They want us to correct the name. So there's a couple of errors here. First off, is the elemental symbol for cobalt Cu, or is it something different? I think it's different, right? Cobalt Co. Cu is copper. So we're dealing with a salt of copper, not cobalt. First major error, okay? Got to know those element names and symbols. Now the second part, iodide. I'm pretty happy with that, I think, okay? I'm dealing with a salt formed from iodide. It's an ionic compound, a metal and a non-metal elemental anion, so I'm going to use that IDE ending. So I'm making some progress here. But again, we've got one of these transition metals that can potentially take on different charge states. We want to tell the world what charge state we're dealing with here. Now, from the stoichiometry of the compound, it's 1 to 1, as stated in the problem. So that tells me right away that I'm dealing with copper 1 iodide. The reason why I knew that is because iodide is one of our halogens. It's the same group or column of the periodic table as fluorine and chlorine, bromine, likes to form the -1 ions when forming the ionic compounds. As a result, to make things charge balanced, my copper has to be +1, and I'm dealing with copper 1 iodide. Okay? So that fixes 2 errors. All right, moving on to part B. We've got this compound. They claim the proper name for this material is iron 2 sulfate. Let's take a look at that for a second, okay? Well, I've got some iron, that's Fe, so that makes a little bit of sense, right? So I can confirm the presence of iron. But what about this ion? I've got a parentheses with a 3 down here and HSO4 in parentheses. So it looks like, from the terminology, I've got 3 copies of that for one of these. Okay, I kind of understand that in terms of the balancing of charges. But is this ion called sulfate, or is it called something else? Turns out it is not sulfate. Sulfate is SO4, 2 minus charge. This is HSO4, and it's actually a -1 charge, not a -2. So because we're not dealing with the same polyatomic ion, we have a different name for this polyatomic ion. We could call this one either hydrogen sulfate, or sometimes it's called bisulfate, okay? So I'm going to just call it hydrogen sulfate here. Okay, so it's not sulfate, it's iron hydrogen sulfate. But it turns out I'm not completely done yet either, because I have not specified my charge state of my transition metal, the iron here. I should do that. Now I just mentioned that this is the hydrogen sulfate or bisulfate anion. Each one carries a -1 charge, and I've got 3 of them. How can I offset that -3 charge? Well, given the 1 to 1 combination ratio between the ions, the cation and the anion, I must be dealing with iron 3 hydrogen sulfate or iron 3 bisulfate. Both of those names would be equally valid, right? So this is the answer for B. All right, now my personal favorite, down here in letter C. I'm given this formula, MgCr2O7, and they decide that the name for this is magnesium dichromium heptoxide. Magnesium dichromium heptoxide. Now, if you come up with that name on a test for this compound, you might be feeling pretty good about yourself, right? And the reason why is because it makes a little bit of sense, based on some of the prefixes and things that you've learned. But the problem is that it's not correct name of this material. Okay. Now we do have Mg. And Mg, of course, is magnesium. So that's a pretty good place to start. I also recognize this compound as being an ionic compound, just like the ones before. Magnesium likes to form these +2 cations, and it's paired up with something else. It's an anion, or a negatively charged ion. So the question is here, the hard part of this question, I suppose, is, well, what in the world is it, in fact, paired up with? Well, it looks like it's paired up with this, Cr2O7. Now, if I don't know what that is, I might call it dichromium heptoxide, I suppose, right? It's at least a little bit logical. But it turns out that this grouping, or combination, or cluster of atoms to form an ion is one of our polyatomic ions that we're learning about, okay? This one is called dichromate. It's called dichromate, okay? Now the dichromate ion has a -2 charge. -2 for this cluster. And I said earlier that magnesium, being in group 2A, likes to form 2 positive. So I've got 2 positive, 2 negative. The charge is balanced to form this work, okay? So it seems like I could call this one magnesium dichromate. And I'd be set. All right, so this is 293.